Good afternoon, students. Today we'll discuss new concept, that is binomial theorem. So this is a new chapter of your class 11. So this concept is based on new concepts like factorials and also binomial expansion. So this is very important topic and very important chapter. Everyone should focus on. So actually, this concept will start from some basic concepts like, see, for example, you know the formula of a plus b whole square. So what was the expansion of this a plus b whole square? You know that this is a square plus 2ab plus b square, and also you know the expansion of a plus b whole cube, right? What is that? That is a cube plus 3a square b plus 3ab square plus b cube. Do you know the formula of a plus b whole power 4? A plus b whole power 4. Do you know the formula? So that is a plus b whole square into a plus b whole square. Can we write? A plus b whole power 4 we can write whole square into whole square. So what is a plus b whole square? That is a square plus 2ab plus b square. And again this is as a square plus 2ab plus b square. See, if you multiply this, if you simplify this, what you will get is, so formula of a plus b whole power 4 is a power 4 plus 6a cube b plus this is 4a cube b, this is 6a square b square plus 4ab cube plus b power 4. This one you should get. See, let us simplify that. See, a square into a square is a power 4 plus 2ab, a square into 2ab is 2a cube b. Why? Because a square into a is a cube b plus a square into b square is a square b square. Now with 2ab into a square is 2a cube b plus 2ab into 2ab is 4a square b square, right? Next, plus 2ab into b square is 2a b cube plus, now with b square into a square is a square b square plus b square into 2ab is 2a b cube. Why? Because b square into b is b cube. Next, b square into b square is b power 4. Now let us sort out this. So this is a power 4. Next, 2a cube b plus 2a cube b is 4a cube b, right? Next, a square b square plus 4a square b square. 1 plus 1 plus 4, nothing but 6a square b square. So this is over, and this is over. Next, 2ab cube plus 2ab cube, which is equal to 4ab cube. Next, plus b power 4. See, without simplifying these 1, 2, 3 steps, directly you can write this. See, I will write a plus b whole power 5 formula also. A plus b whole power 5 formula also. See carefully. See, this is a power 5 plus 10 a power 4b plus, so this is a 5 a power 4b plus 10 a cube b square plus this is 10 a square b cube plus 5 ab power 4 plus b power 5. So this is what the formula of a plus b whole power 5. Not only up to a plus b whole power 5, I will write a plus b whole power 6, a plus b whole power 7. So those are formulas in our mind. So these formulas I did not by heart, but these formulas not only a plus b whole power 5, a plus b whole power 10 also I will write, a plus b whole power 9, a plus b whole power 8, immediately I can write by using binomial theorem. How we can explain by using binomial theorem? We can learn to it. So actually here power a plus b whole square is 2, 3, 4 and this 5. These we will consider as index. Index is nothing but simply we will call it as power of the terms. Index. Whole square, whole cube, like this. Those we will consider as index. See, if the index is 1, see, if it is a plus b whole power 1, what was that? A plus b. If it is a plus b whole power 0, it is 1. Why? Because anything power 0 is equal to 1. Now here some minimum things we can observe. So what are those? Means If index is equal to 0, how many terms you are getting? Index 0 means how many terms you are getting? One term. Nothing but 0 means 1. If it is 1, how many terms you are getting? A plus B. If index equal to 1 means how many terms you are getting? 2. If index is equal to 2, how many terms? 1, 2, 3. 2 means 3 terms. Next, 3 means whole cube. 3 means 1, 2, 3, 4. 4 terms. If it is 4, if it is 5, if it is 5, if it is 6, you can check. Here if it is 5, 1, 2, 3, 4, 5, 6. Like that. If index is equal to n, then number of terms in an expansion. Number of terms in an expansion a plus b whole power n is equal to how much? N plus 1 terms. Understand? If that index is equal to 10, that means number of terms in that expansion a plus b whole power 10, which is 10 plus 1, nothing but 11. Here one thing you need to consider, in that index by using binomial theorem or binomial expansion, that index should be positive integer. Here 0 also you will consider here. Including the positive integer, 0 also you will consider. Here we won't consider negative numbers like -1, -2, and again -3/4 fractions like 4/5 and pi. So these all we won't consider, right? Negative numbers and rational numbers, nothing but fractions, and these pi, omega, those values also we will consider. We will consider only positive integers, and we can define these formulas. So this is about how we can write those. See, pause the video to note it down. Next, we will discuss about Pascal's triangle. Based on index. See, in that Pascal triangle, what they will define is, they define the coefficients, how to find coefficient. See, for example, if the expansion is, this is a plus b whole power 0. Here I will write indexes. Here I will write coefficients. If here, what is the index here in this a plus b whole power 0? Index is 0. If index is 0, what is the coefficient? Coefficient we got is 1. See, whatever it may be, see the only one term we got now, that is 1. Next, in the expansion of a plus b whole power 1. So what is the index? Index is 1. If index is 1, what are the coefficients we got in that expansion? A plus b whole power 1 means coefficients are here 1, here 1. Coefficients are nothing but the before value, numerical value. This is 1 and 1. So here I will write 1, here I will write 1. Next, in the expansion of a plus b whole square. So what are the coefficients we got? 1, 2 and 1. So this is what? 1, and this is 2, and this is 1. Next, a plus b whole cube. Here what are, in this expansion, what are the coefficients we got? 1, 3, 3, 1. So I will write 1, 3, 3, 1. Here from this coefficients, you can understand another thing. See, from this, from this, 1 and 1 which is equal to 2. Next, 1 and 2 which is equal to 3. Here 2 and 1 which is equal to what? 3. So like this, based on these triangles, the values will be there. See, let us write another one. If it is a plus b whole power 4, what we got? 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. So these are the coefficients, right? So 1, 4 when we will get 1 plus 3, 6 when we will get 3 plus 3, 4 when we will get 3 plus 1. Next, you can tell easily. See, without knowing the formula of a plus b whole power 5, without knowing this formula a plus b whole power 5, easily you can tell what are those coefficients will be. So they are like 1, 5, 4 plus 6, 10, 6 plus 4, 10, and 4 plus 1, this is 5, and next one is 1. Right? So this is what we will consider Pascal's triangle. Right? Here if you observe 1, 5, 10, 1, 5, 10, next 10, 5, 1, 10, 5, 1. So next one you can tell easily a plus b whole power 6. What are the quotients? Maybe a plus b whole power 6, 1. So 1 plus 5 is 6 here. Next 5 plus 10 is 15 here. Next 10 plus 10 is, here we will get 20. Next 10 plus 5 is, here we will get 15. 5 plus 1, this is 6, and next one is 1. So next go on, it will continues up to what? Up to a plus b whole power n, where n is an positive integer, right? So this triangle, this condition we consider as Pascal's triangle. See, based on this Pascal's triangle, you can define any expansion of a plus b whole power n, whatever it may be the n value. It may be 10, 19, whatever it may be, you can write by using this expansion. Now what are the things you need to focus here is, first point, note points. If index is equal to n, then number of terms is equal to n plus 1. Nothing but, if it is index means power 10 means 10 plus 1 11 times. If it is 6 means 6 plus 1 7 times. Another thing you need to focus, in the expansion, if you observe these terms, if you observe this each and individual terms, sum of those powers should be equal to that index. In individual terms, sum of powers of the variables, sum of the powers of the variable is equal to index, should be equal to index. If you observe here, a power is what? 3. 3 is equal to this index or not? Next, in this term, a square b, here 2 is there, here 1 is there. 2 plus 1 is what? 3. Next, here a power 1 is there, here b square is there. 1 plus 2, 3, here also 3. And again here it is 1, 1, here it is 1, 1. Next, here 2, here 1, here 1, 1 plus 1, 2, here 2. Next, in a plus b whole power 4, this is 4. Next, a cube b, 3 plus 1, 4. Next, 2 plus 2, 4. 1 plus 3, 4. This is also 4. Next, in 5. So this is 5. 4 plus 1, 5. 3 plus 2, 5. 2 plus 3, 5. 1 plus 4, 5. This is also 5. Now, based on this condition and also based on this Pascal's triangle, we can write or not a plus b whole power 6. Can we write or not a plus b whole power 6? Tell me, a plus b whole power 6. First one should be a power 6 according to this expansion. First one is a power 6. Next one, what is there here? 6. So 6 a power 5 into b. So first term a one thing we need to decrease, b one thing we need to raise. Right or not? See here we can write a power 6 into b power 0. Next, a power 5 into b. Next, what is there? 15 a power 4 into b square. Again a decreased once, b increased once. Next after 15 what is there? 20 a cube b cube plus after 15 a square b power 4. Next 6 a into b power 5 plus b power 6. Did you understand? Like that we can expand any expansion of a plus b whole power n form. Pause 0 to note it down. Now, for example, if we have a plus b whole square, we have a square plus 2ab plus b square, right? See, what is the formula for a plus b whole power n? See how we can write those n plus 1 terms will be there now, right? For example, here 2 means 1, 2, 3. 2 plus 1, 3 times will be there. Like that, a plus b whole power n. N means how many times it should have? N plus 1 times. What are those n plus 1 terms? In that n plus 1 terms, what are the middle term? What is the sixth term? What is the eighth term? Right? See, for example, in this a plus b whole power 6, if you want to write that expansion, means easily by using that Pascal's triangles and also by adding those sum of powers, easily you can write that expansion, right? So like this also you can write some more terms you can write. But in the a plus b whole square, so what is the second term? What is the first term? What is the third term? We can tell. Why? Because we know the formula. Now in this a plus b whole power n, what is the 250th term? What is 100th term? What is the 900th term? What is the 9th term? How we can define? See, we can define by using an binomial expansion. By using binomial expansion. But to understand that binomial expansion, we need the concept of factorials that we will discuss today. See, what do you mean by factorial? What do you mean by factorial? See, generally this factorial is denoted by the letter R, like this, or like this, like R exclamatory symbol. So this one we will consider as R factorial. This one we will consider as R factorial. If we write like this, we will consider as 5 factorial. This is what? 10 factorial. This is what? 2 factorial. We will read it as 2 factorial, but we will write it as 2 into that exclamatory mark we use. Or instead of this exclamatory mark, we can also use this symbol. Right? See, under this symbol, we need to write either 5 or 6 or whatever it may be the factorial. But in the 99%, we will use this symbol only. Right? In rare cases, we will use this. If they mention in question paper like this, we need to use like that. So otherwise, we can write it like this. In almost every books, they will represent like this one. Right? So we will follow this one only. Now, what do you mean by an R factorial? See, for example, so the value of 1 factorial is equal to 1. Value of 2 factorial is 1 into 2 is 1 into 2. Nothing but 2. The value of 3 factorial is 1 into 2 into 3, which is equal to 6. Value of 4 factorial is 1 into 2 into 3 into 4, which is equal to 24. Value of 5 factorial is 1 into 2 into 3 into 4 into 5, which is equal to 120, 5 24s. Next, 6 factorial. So 1 into 2 into 3 into 4 into 5 into 6, which is equal to 720. So like that, so on. So now what you understand by using this factorial means the product of the terms from 1 to n. If it is n factorial. Nothing but 1 into 2 into 3, so on up to what? So on up to n. As like 5 factorial. 5 factorial means product of those numbers from 1 to 5. 1, 2, 3, 4, 5. 3 factorial means 1 into 2 into 3. That is 6 factorial. Like that we will write factorials. And again we have 0 factorial also. See, you can tell, sir, 3 factorial means 1 into 2 into 3 will do. Or 3 into 2 into 1. So you can write in ascending order or descending order also, no problem. See, 3 factorial you can also write like 3 into 2 into 1, which is again same. 4 factorial again you can write as 4 into 3 into 2 into 1, which is equal to 24. As you wish, you can go. Now, see how we can write, sir, 0 factorial. We need to start from 1. So 1 into 2. 2 like that we cannot write now. Why? Because 2 factorial means maximum up to 2. 3 factorial means maximum up to 3. 4 factorial means maximum up to 4. But this way, the value of 0 factorial we will find by using reverse process. See, for example, 6 factorial is 620. How we can get 5 factorial? How we can get the value of 5 factorial from 6 factorial? If we divided 6 factorial by 6, 6 factorial by 6, what is 6 factorial? 720. 720 divided by 6, what you get? 120. Now again 120 to 24, how? Divided by 120 by what? 5. Nothing but 5 factorial by 5. If you do, what you will get? 24. Again, when we will get 6? Nothing but if we divide 4 factorial by 4, what you will get? 3. Nothing but 6. 24 by 4 is 6. Next, when we will get 2? 6 by 3, if you do, what you will get? 2. And again, now 2 by 2, if you do, what you will get? 1. Again, to this step, 1 by 1 is equal to 1. Right? Now, why in that factorial, in the expansion Pascal triangle, and also in the indexes, why I told negative numbers and fractions not allowed means if we take minus 1 factorial, how it should occur? So divided by this number, nothing but 1 by 0 it should be. So 1 by 0 is undefined. So that's why when come to r factorial, r should be equal to positive integers. R should be equal to positive integers including 0. So we cannot write minus 1 factorial, it's wrong. We cannot write a 3 by 4 factorial, it's wrong. We cannot write pi factorial. Why? Because we know the pi value 3.14, it is in decimals, so it is wrong. So we cannot define the negative factorials, and we cannot define fractions, and we cannot define those pi values and all those. So what we can define is from 0, 1, 2, 3, 4, 5, 6, 7, 8 up to so on up to n factorials we can find. And also one thing you can observe, see if it is 5 factorial, how we can write 5 factorial? 5 into 4 into 3 into 2 into 1, right? Which is equal to 120, right or not? 5 4 20, 23 60, 62 120. Now this 5 factorial we can also write like 5 into 4 factorial, correct or not? Observe, 5 into, what is this? 4321. That 4321 is equal to 4 factorial. So nothing but 5 factorial we can write as 5 into 4 factorial, right? Now again, now this 4 factorial we can write as 5 factorial by 5. 4 factorial also we can write as 5 factorial by 5. That means 10 factorial we can write 11 factorial by 11, right? 10 factorial we can write 11 factorial by 11. Why? Because how we can write 11 factorial? 11 factorial into 11 into 10 factorial we can write, divided by 11, 11 cancel, which is equal to 10 factorial. Nothing but 5 means 5 into 4 factorial, or 5 into 4 into 3 factorial, right or not? Here this one also we can write as 5 into 4 into 3 to 1, nothing but 3 factorial. Like that also we can write. See, as per the question demands we can write. Or there in terms of 5 into 4 into 3 into 2 factorial also we can write, or 5 into 4 factorial, or 5 into 4 into 3 factorial, or simply 5 factorial, or substituting that 5 factorial value 120. By any way, based on the demand of that question we can write, right? So this is about the factorials. See, to find these factorials we have some formulas. So the formula is nothing but simply product of the numbers from 1 to that same number. So that gives the factorial values. And again we have some formulas which is based on permutations and combinations. That formula also we will discuss. So pause the video to note it down. See, note down these 4 important formulas. See, from these 4 formulas we are going to solve any problem in the binomial theorem. So the formulas are nothing but very simple values. Those are n factorial, nothing but factorial. N factorial means what? Product from 1, 2, 3, so on up to n. Or we can also write like in a descending order, like n, next n minus 1, like 5 means 5 into 4, 5 minus 1, 5 minus 2, like. So n into n minus 1 into n minus 2, so on up to 3 into 2 into 1, right? And at the same time, n factorial we can also write like n into n minus 1 factorial, right? Like 5 factorial means 5 into 4 factorial, or we can also write like n into n minus 1 into n minus 2 factorial, or into n minus 3 factorial based on our requirement. Next, NCR. So n factorial by n minus r factorial into r factorial. Now maybe this is the first time you have seen that NCR. In some ICSE syllabus also it maybe will be there. But that NCR, what do you mean by that NCR? In that Pascal's triangle, so we have saw these numbers, right? So 1, 2, 1, this 1, 3, 3, 1, like. When we will get this one? If it is a plus b whole power 0, this is a plus b whole square, this is, so this is a plus b whole power 1, this is a plus b whole square, this is a plus b whole cube. Now see, what do you mean by that NCR when we will use in this expansions? By using this Pascal's triangle. If you observe this, these are 1, 1, 1 and 1, 1, 1. For any expansion, first and last term coefficients are equal to 1 and 1. Next, this is 2, right? next 1 plus 2 3, next 1 plus 3 4, next 1 plus 4 5, like that it will continuous. You already learned that. Now, so when we will get these values is, see if it is a plus b whole power 0, that value 1 will get from 0c0. If it is a plus b whole power 1, this one value will get through 1c0, this one value will get 1c1. If it is a plus b whole square, this 1 will get through 2c0, this 2 will get 2c1, this one will get from 2c2. If it is a plus b whole cube, this will get 3c0, 3c1, 3c2, this is 3c3. If you observe that simple logic, for a plus b whole power 4, did you observe this a plus b whole cube? See, it is in the form of NCR, right? Like 3 numbers are there now, N, C, R. C is common here, and N and R, both values will be there. If you observe this a plus b whole cube, 3c0, 3c1, 3c2, 3c3. That means that above number is equal to n. That n is nothing but index. N is nothing but index. So that is constant. So 3 means for all those, that upper value will be 3. Next, what about those down that R values? That R values are, so whatever may be the index. For example, if the index is 3, so those R values will be like 0, 1, 2, 3. As we know that if index is 3, number of times are 4, right? 1, 2, 3, 4 times. In that 4 times, starting from 0, 1, 2, 3. Understand? If index is 4, how many times we should get? 5. So those are 4c, 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 4c. 5 times, right? 1, 2, 3, 4, 5. In that 5 times, what are those R values? R values start from 0. So 0, 1, 2, 3, 4. So these only will be converted into coefficients. Those only will be converted into coefficients. See, what are the coefficients of a plus b whole power 4? So you know that. So first one will be 1. So actually what is the formula of a plus b whole power 4? That is a power 4 plus 4a cube b plus 6a square b square plus 4ab cube plus b power 4. So this is the formula. In that formula, coefficients are 1, 4, 6, 4, 1. So those also equal to 4c0, 4c1, 4c2, 4c3, 4c4. So those values are 1, 4, 6, 4, 1. How we can find? See, why this 4c1 is equal to 4? Why 4c2 is equal to 6? Why 4c3 is equal to 4? We will find by using the formula NCR. So that NCR is equal to n factorial by n minus r factorial into r factorial. But here conditions are there. Conditions are r should be greater than or equal to 0. N should be greater than or equal to 0 where n belongs to integer. N should be greater than or equal to 0 where n belongs to integers. Like 0, 1, 2, 3, so on. Only positive integers. Condition given greater than 0. Now what about r? R should be greater than or equal to 0 and should be less than or equal to n. R should be greater than or equal to 0, less than or equal to n. That means it shouldn't be like 5c10. R should be less than or equal to n only. It shouldn't be greater than. So 5c10 is wrong, we cannot define. And 5c6 we cannot define. But 7c5 we can define. Why? Because this n belongs to integer and this r is less than or equal to and greater than 0. So 7c5 we can find. Now how to find those 7c5 values, 4c0, 4c1 values? How we can define? We can define by using NCR, which is equal to n factorial by n minus r factorial into r factorial. See, let us solve few examples. For example, if we take 4c0, that first value, if we take 4c0, so n value 4, r value 0. If we apply in this formula, 4 factorial by n minus r, 4 minus 0, 4 factorial into r factorial. What is r? 0. So 0 factorial. So 4 factorial by 4 factorial cancel. 1 by 0 factorial. We know 0 factorial is equal to 1. 1 by 1 is equal to 1. So that is what 4c0 is equal to 1a power 4. Right. Next, by using the same formula, 4c1 I will do. What is 4c1 according to this formula? 4 factorial by 4 minus 1 factorial into 1 factorial, n factorial by n minus r into r factorial. What is 4 factorial? 4 factorial is equal to, say, 4 factorial divided by 4 minus 1 is 3 factorial into 1 factorial. As we know that 4 factorial we can also write like 4 into 3 factorial. So 3 factorial cancel. 4 by 1 factorial. 1 factorial value 1. 4 by 1 is equal to 4. So that is what 4c1 is equal to 4. Like that, if you find 4c2, 4c3, 4c4, you will get these values. Understand? So like this, we will find these NCR values. It may be 7c5, 6c3, 8c1, 8c2. Any values we can find by using NCR formula. Pause the video to note it down. Next we will go through next formulas. Next the formula number 3, that is NCR is equal to NC n minus R. NCR is equal to NC n minus R. See, for example, I will consider n is equal to 4, R is equal to 2 I will take. NCR is equal to NC n minus R. Why? And both are equal or not, once we will check. NCR, if the values are n equal to 4, R equal to 2. What is NCR? 4c2. They are telling that according to this formula that 4c2 is also equal to 4c. If we take any R equal to 3. If we take R equal to 3. So NCR means 4c3. That also should be equal to NC n minus R. N minus R. Nothing but 4 minus 3, which is equal to 1. So according to this formula, 4c3 is also equal to 4 minus 3. Nothing but 4c3 is equal to 4c1. Correct or not? Let us check. What is 4c1 value? 4. What is 4c3 value? 4. So these two are equal or not? Right. Next, again 7c5. The value of 7c5 is also equal to 7c2. If you have a doubt, you can check. Why? Because 7c5 is also equal to 7c. 7 minus 5, 2. Why we can? What is the use of writing this 7c5 is equal to 7c2? What is the use of this? Means, see, in order to find the value very simply. Another thing is, see, if we write 4c3, send the shortcut method instead of using this formula. So actually this 4c3 is also in the form of NCR, right? NCR formula is n factorial by n minus r factorial into r factorial. But another shortcut to find the value directly is, if it is 4c3, 4 you decrease 3 times. 4 you decrease 3 times. 4 into 3 into 2. Only 3 times. That means 3 numbers. 4, 3, 2. Divided by, here down 3 is there now. 3 you decrease. 3 into 2 into 1. Now you simplify 3, 3, 2, 2 cancel. What is that? 4. That's what 4c3 value. 4. Next. 7c5. Instead of using this formula, 7c5, value of 7c5 is 7 you decrease 5 times. 7 into 6 into 5 into 4 into 3. 7c5 means 7 not decrease up to 5. Decrease 5 times. 7, 6, 5, 4, 3. 5 times you decrease. Divided by, what is there? 5. What is there? 5. 5 you decrease. 5 into 4 into 3 into 2 into 1. Now 4, 3 cancel. 5 cancel. 2 1s are 2 3s are nothing but 7 3s 21. Value of 7c5 is 21. If you check through this formula also, you will get same. But why we are using this one is, why we are using this third formula, NCR equal to NC n minus R, means instead of finding 7c5 value, which includes the cancellation of all these numbers, instead of this 7c5 is also equal to 7c2. 7c2 means 7 you decrease 2 times. 7 into 6. 2 is there not? 2 you decrease. Now 2 1s are 2 3s are 7 3s are 21. Right? Did you understand now? Now instead of simplifying all this one also you can simplify. When we can use the third formula is, if they ask us to find 100C99, They ask you to find 100C99, nothing but 100 you will decrease 99 times, and again denominator 99 you will decrease. Otherwise, instead of this formula, we can use this third formula, that is 100C99 is also equal to 100C 100 minus 99, which is equal to 100C1. 100C1 means 100 you decrease one time, 100 divided by 1, which is equal to 100. Value of 100C99 is 100. So like that we will use the formula NCR is equal to NC n minus R. Next formula, the last but not least, that is formula number 4. NCR plus NC n minus R is equal to n plus 1 CR. See, this formula we will also use in the binomial expansion and also in some of the major form problems in the binomial theorem. We will use this formula. This is very important. NCR plus NC n minus R is equal to n plus 1 CR. So let us take n is the value of 5 you take and R the value of 3 you take. That means according to this formula, 5CR nothing but 5C3. 5C3 plus 5C n minus R, 5 minus 3, 5C2. So nothing but the value of 5C3 plus 5C2 is equal to n plus 1. So 5 plus 1, 6CR. What is R? 3. So value of 5C3 plus 5C2 is equal to 6C3. Like that, value of 7C4 plus 7C3, which is equal to 8C4. So you can check this. What is 5C3 value? 5 you decrease 3 times, right? 5 into 4 into 3 divided by 3 you decrease 3 into 2 into 1. 3 3 cancel, 2 1s 2 2s, 5 2s are. This is the value of this 5C3 is 10. Next 5C2. 5 you decrease 2 times, 5 into 4 divided by 2 into 1. 2 1s are 2 2s are, 5 2s are, again it is 10. Nothing but 10 plus 10, which should be equal to 20, right? So now what is the value of 6C3? 6C3 means 6 you decrease 3 times, 6 into 5 into 4 divided by 3 you decrease 3 into 2 into 1. Nothing but 3 2s are 6, 5 4s are 20. So that 20 is equal to this 20, right? So nothing but this formula also we can use in the problem solving whenever it is required. So these are the 4 important formulas to solve the starting basic problems of binomial theorem. In tomorrow's class, we will learn that expansion, nothing but a plus b whole power 4. Why it is this one? Why it is a power 4? Why it is a cube b? Why not here this one should be 4a square b square? Why not this 4a cube b here, a b cube here? Why not here we should write b power 4? So those all things we will discuss by using binomial expansion. That expansion will comes for you for 5 marks. The only 5 marks question in this chapter is binomial expansion, that we will discuss tomorrow. Now I will do problems based on these factorials and based on these 4 formulas. See, for example, how the questions will be like. Questions will be like x by 5 factorial plus 1 by 6 factorial is equal to 1 by 7 factorial. So find the value of x. Find the value of x. How to find this? See. So this is x by 5 factorial plus 1 by 6 factorial, we can write as 6 into 5 factorial. 6 factorial we can write as 6 into 5 factorial, which is equal to 1 by 7 factorial. 7 factorial we can write 7 into 6 into 5 factorial. Why I express it like this? Why? Because from all these we can take 5 factorial common, right? So if we take 1 by 5 factorial common, here it will be x, here it will be 1 by 6, which is equal to, so here it will be 1 by 6 sevens, 7 into 6 into 5 factorial. So 5 factorial cancel. Here it will be 6x plus 1 by 6 is equal to 1 by 7 into 6. 6 cancel. 6x plus 1 is equal to 1 by 7. So 6, like that we can find that x values. Not only x values, whatever they will do, we can find. Another thing you need to remember is 3 factorial plus 4 factorial is not equal to 7 factorial. 3 factorial plus 4 factorial is not equal to 7 factorial. Why? Because what is the value of 3 factorial? 3 into 2 into 1, nothing but 6. What is the 4 factorial? 24. So which is equal to 30. but 7 factorial value is much more higher when compared to 3 factorial plus 4 factorial. So that's why it is not equal to 7 factorial, right? So these are the basic things of factorials and factorial notation. Factorial notation is nothing but representing that n like this. So this is nothing but factorial notation. We can also read it like n factorial, 5 factorial, 3 factorial like that. See, based on these four formulas, I will give assignment. Thank you for watching. Thank you. Have a nice day.